Hello and welcome back to Engineers Olympiad, where learning meets success. We're discussing the basic forms of bridges. There are 7 basic forms of bridges. The first one is beam bridge or girder bridge. The next one is there is a beam bridge or a girder bridge. Then we have truss bridge, then arch bridge, then cantilever bridge, fifth one is suspension bridge, then we have a cable stayed bridge, and the last one is a bowstring bridge or a tied arch bridge. All right, so there are 7 basic forms of bridges: beam bridge or a girder bridge, truss bridge, arch bridge, cantilever bridge, suspension bridge, cable stayed bridge, and a tied arch bridge. We have discussed all these. Now the one that's remaining is a tied arch bridge we're going to study today in this video lecture. Tied arch bridge, which is also known as a bowstring bridge. So this is our discussion for today. Tied arch bridge, also known as bowstring bridge. Why so? We'll discuss. So the tied arch bridge is an arch bridge in which the outward directed horizontal forces of the arches are borne as tension by a cord tying the arch ends rather than by the ground or the bridge foundation. First, let me show you diagrammatically. This can be the one support, this may be the other. This is known as a tied arch bridge, wherein these are hangers or suspenders. This is the bridge deck, this one. This is arch rib. And this is tying cord or ties. All right, so arch bridge is an arch bridge in which the outward directed horizontal forces of the arches are borne as tension by a cord tying the arch ends together rather than by the ground or the bridge foundation. So in case of arch bridges, the horizontal forces of the arches are borne by the bridge foundations. And abutments. But in case of a tied arch bridge, these horizontal forces are borne by a cord which ties the two ends of the arch together. That means, let me draw it first. If this is the arch, this is the springing level, this is the springing level. Springing level means the starting point of the arch's curve So in case of simple arch bridges, these arches were positioned beneath the deck. So deck used to be here, and the arches which support the deck in case of arch bridges were positioned beneath the deck, be it one arch or more than one arch. But in case of tied arch bridge, deck is over here. So this arch rises above the deck, and the two ends of the arch are tied by a cord, which is known as the tying cord or a tie, which are essentially constitute some tie members. These ties or this tying cord bears these horizontal forces instead of the bridge foundations or the supports. What are the advantages of going for these tied arch bridges? We'll study. So the deck is positioned below and the arch rises above it in case of a tied arch bridge. Tied arch bridge, that's why it's known as tied, because the two ends of the arches are being tied by a cord, which is known as a tying cord or a tie. All right. Now this strengthened cord may be the deck structure itself, the tying cord. This may be the deck structure itself of that tied arch bridge. Or it may consist of separate, independent tie rods. All right. So this tying cord may be the deck structure itself, or it may consist of separate, independent tie rods. I'll show you one diagram. This is a steel bowstring girder type bridge. This is the arch rib. These are the hangers or suspenders. This is the bracing, as we do it in case of steel bowstring girder bridges. And this is the tie, or this is also the deck of that tied arch bridge. So the tying cord or the tie may be the deck structure itself, or it may consist of separate, independent tie rods. All right, in case of a tied arch bridge. Now the elimination of horizontal forces at the abutments, since horizontal forces in case of a simple arch bridge are borne by supports or foundations or abutments, but in case of a tied arch bridge they are borne by the tying cord, which may be a deck structure itself, or it may consist of separate independent tie rods. This must be noted. Now this elimination of horizontal forces at the abutments allows tied arch bridges to be constructed with less robust foundations. Since we discussed in case of arch bridges that their limitations was due to inclined reactions at the supports, heavier sections had to be designed for their supports. But in case of a tied arch bridge, this advantage of using a tied arch bridge is that the elimination of the horizontal forces at the abutments allows this tied arch bridges to be constructed with less robust foundations. Thus, they can be situated, let me drop it first, atop piers. They essentially rise above the deck and are not placed below the deck in case of arch bridges. All right, so less robust foundations need to be designed in case of a tied arch bridge, because there is elimination of horizontal forces that are borne by the abutments or the supports. Rather, the horizontal forces are borne by the tying cord, which ties the two ends of the arch together at the springing levels of the arch. All right, so they can be situated, these tied arch bridges can be situated atop elevated piers or in an area or areas where there are less favorable soil conditions or there is unstable soil. since the arch, in case of a tied arch bridge, rises above the deck, this is the deck or the tying cord, this is the rib, and these are the suspenders. All right. The two ends of the arch at the springing levels are tied together by the tying cord, which may be the bridge structure itself or may consist of separate independent tie rods. All right. So the advantage is that they can be situated, since we have to go for less robust foundations because horizontal forces are borne by this tying cord. So they can be situated atop elevated piers or in an areas with less favorable soil conditions, because we don't have to go for more robust foundations. So they can be used in areas with less favorable soil conditions. All right. Moving on, let me rub it first. So what we discuss, so this bowstring bridge or this tied arch bridge essentially consists of two arches which are tied horizontally. Let me rub it first. So these bowstring bridges consist of two arches, one on either side of the bridge, and they are tied, as already discussed, horizontally at the springings by using tie members or tie rods. Now, what is the function? So that the reactions at the supports will only be vertical and not inclined. Since in case of arch bridges we had inclined reactions at supports, but by tying the arch horizontally at the springings by using tying cord or tie members, the main advantage is that the horizontal forces are borne by this cord, so that reactions at the supports are only vertical and not inclined. So we have to go for less robust foundations, so they can be situated atop elevated piers and can be used in areas where there are less favorable soil conditions. And this structure, a tied arch bridge, this combines the advantages of two hinged arches, at the same time eliminating the main difficulty of the arch supports. That is, what is the main difficulty of arch supports? That is horizontal thrust at each support and the inclined reactions thereof. All right. So this tied arch bridge or a bowstring bridge, it essentially combines the advantages of two hinged arches, at the same time it also eliminates the main difficulty of arch supports, that is horizontal thrust at each end or inclined reactions at the supports. Horizontal thrust or / inclined reactions at the supports. All right. So this is about the tied arch bridge. Did you notice something? That this type of bridge is essentially a combination of two different bridge types, or rather it combines the characteristics of two different bridge types. Can you name them? So in the tied arch bridge, you saw that in diagram. I'll make it once again for you, or I can show it here in the diagram. So in case of a tied arch bridge or a bowstring bridge, the characteristics of suspension bridge and arch bridge are combined together. This is your tied arch bridge. These are the supports. This is the bridge deck or a tying cord. The tying cord may be the bridge deck itself or may consist of separate independent tie members, as already discussed. These are the suspenders or hangers. This is arch rib. These are the suspenders. So can you see that the characteristics of two different types of bridges are combined together? This is essentially a suspension bridge because the deck is suspended from the arch and connected by means of these suspenders. So in case of a tied arch bridge, the deck, this is the bridge deck, this also remains suspended as in case of a suspension bridge from the arch. The deck is suspended below the arch and is connected to it by means of these hangers or suspenders. And this is essentially an arch bridge, and this is form of a suspension bridge because deck in case of a tied arch bridge remains suspended below the arch and is connected to it or is suspended from it by means of these suspenders. So the characteristics of a suspension bridge and an arch bridge are combined together in this tied arch bridge or a bowstring bridge. Now, why is it known as a bowstring bridge? It derives its name from the shape. Tied arch bridge, we can easily relate why it's known as a tied arch bridge because the two ends of the arches are tied together by a tying cord at its springing levels. Now, why is it known as a bowstring bridge? It's known as a bowstring bridge because it derives this name from its shape. As you can see in the diagram, the arch rib and the tie, this respectively resembles bow and string. So since it resembles a bow and string, that's why it's known as a bowstring bridge. So the flooring in case of, this is the bridge flooring, I'll show you in the diagram. The flooring or the deck. The flooring in case of a tied arch bridge, this rests on ties and the load is transmitted to the arch rib through these suspenders. The vertical loads that come on the arch bridge is transferred to the rib by means of these hangers or suspenders. And suitable bracing may also be provided in case of steel bowstring girder bridges that you're seeing over here in the diagram. We have also provided steel bracing. Now, as already discussed, and the basic advantages of going for these bridges is that, number one, the horizontal thrust, as already discussed, is resisted by the tying cord or the ties. Hence, the reactions at the supports are only vertical and not inclined. As in case of an arch bridge, we have inclined reactions at the supports. So as a result of vertical reactions, we require lighter sections, unlike heavier sections in case of a supports of an arch bridge. First, second one, we already discussed that they can be made of use or put into use rather. Let me rub it first. In those areas where there are less favorable soil conditions. And in addition to this, we had also discussed one biggest disadvantage or a drawback of arch bridges, if you may recall the discussions as held in that particular video lecture. What was that? That in those areas where the available vertical clearance was restricted and we had to accommodate the rise of the arch between the springing level and the approach level of the road, there was a problem. Now let me rub it first. But in case of a tied arch bridge, there is no such thing. Why? Because the deck, in case of the tied arch bridges, the arch, it rises above the deck and it's not placed beneath the deck. The arches are not placed beneath the deck, they rise above the deck. So there is no question of accommodating the arch of the rise of the arch between the springing level and the formation level of road or the approach level of road in case of a tied arch bridge. If you may recall the discussions, if this is the support and this is the support and this is the arch bridge, sorry, I'll make it a better one. Now this is the bridge deck and this is the arch. This is the springing level of the arch. And this is the rise of the arch. This is the formation level or the approach level or the level of approach of road. So in all those cases where an arch bridge had a big drawback, that wherein there was a limited vertical clearance available and the arch had to be accommodated between the springing level and the formation level of road, and they were quite uneconomical in those cases. But here in case of a tied arch bridge, no such drawback is present. Why? Because the arch is not placed beneath the bridge deck, rather it rises above the bridge deck. Hence the problem of accommodating its rise between the springing level and the formation level is not a challenge in case of a tied arch bridge. All right, so the bowstring girder bridges, because they project above the formation level of the road or the railway line, they project above the formation level of road or a railway line for that matter. So the question of accommodating the rise between the level of approaches and the springing level of the arch does not arise. So this is another advantage of going for the tied arch bridges or a bowstring girder bridge. Now these advantages make these type of bridges quite suitable for multiple spans and at those places where vertical clearance is limited. All right. Now we have two types